Okay, I've got a ramp set up, some stacks of books. You can't see the end of it, but you know what I'm doing. I'm releasing a ball. It's going to go to the end of the ramp, and it's going to fall. It's going to hit this piece of paper. When it hits this piece of paper, it's going to leave a little dent. And I'm going to put, just draw a circle at the edges of that dent. And then I'm going to run it again. Okay, the dent isn't quite in the same place. That's to some extent because the paper isn't quite in the same place. So we probably want to tape this paper down. Now, in case I forget it, here I am at the board. The tape is on the first shelf on the cabinet right there. You shouldn't have any trouble finding it. Okay, now see, I've got two little circles on the paper. Now, if I get rid of that sample data, I'm going to put the paper every time right up against the edge of this lowest book, and I'm going to extend the end of the ramp. Whoa, whoa, whoa. The whole thing wants to shift on me. Okay, we got to keep that. And you might want to analyze that occurrence. Okay, I'm going to set this back up. It'll just take a minute. Okay, fortunately my sense of humor is still intact. I've got the system set up again with only 3 books instead of 4. The amount of weight of this system in relation to the balancing of the forces and the torque balances and the coefficient of friction on that end of the board, and the fact that there's not much weight on that end of the board makes a good statics problem. But we'll defer that for the moment. Okay, now we roll the ball. Make sure to line the paper with the edge of the board here and the edge of the book here. We roll the ball down. We notice where it lands. It makes a mark on the paper, and we mark that point. I'm kind of lip syncing this. I did this a minute ago, or a few minutes ago, and forgot to hit the record, so I already have the thing marked, but I'm going to pretend to be marking it now. Just to show you that this can be done rather quickly. You've got one person marking, one person rolling, it can be done very quickly. Okay, that's 3 of them. Now I add another domino. Let's see what difference the second domino makes in the landing point. Okay, mark that, realign the paper, make sure it's lined up the way it always was. Roll it again. Okay, another mark, and roll it again. And another mark. Now third domino. Okay, mark here, realign. We're going to have the paper taped to the floor when you actually do this. You're going to do this off the edge of a table with the ball going all the way to the floor. So you're going to get much better results than what we have here. The marks are going to be pretty distinct. You're going to be able to tell where they are. Anyhow, I don't know if that was 3, I lost count. But we're going to get something that looks very much like this. Straight drop, and then the 3 trials with 1 domino, 3 trials with 2 dominoes, 3 trials with 3 dominoes. We'll have fun analyzing this. When we get into projectile motion next week, and many of you are already adept at analyzing projectile motion, we're going to have some good analysis of the projectile behavior of this system, a fairly challenging analysis. And that's going to give us a way to determine what the final velocity of this ball had to be at the instant it lost contact with the ramp. And the consistency we get in these dots is such that I think this is going to be the most accurate way we have of all the different timing devices and so forth we have in the lab. I think this simple setup is the one that's going to give us the best indication of the actual final velocity of the ball. However, we're going to push that tomorrow. We're going to test that. Okay? So very good.